Hi, my name is Scholz, and I'm going to show you how to set up your Hawkeye II to your radio and how it flies. You'll notice that I have my propeller removed on this airplane, and the reason that you want to do that is anytime that you are working closely with the airplane and the controls, you need to remove the propeller, because if it should start inadvertently, which they sometimes do, you could hurt yourself very seriously. So whenever you're working with the radio and setting up your plane to fly, make sure that your propeller is removed, and that way you will not cut off a finger. Now, this is a completed Hawkeye II, and I have mine. This is a particular version that has what they call the center of gravity kit. And what the center of gravity kit does is it allows you to shift the weight of the fuselage on the sail so that the plane is able to climb faster or descend more quickly. Now, if you look at the plane itself, I'm flying what we call which is a 3300 3S battery. This plane is fully capable of taking a variety of battery sizes. So if you want to use a 2500 or two 2500s or one 5000, whatever, this plane is capable of using it. But remember that each time you change your battery weight, you're going to change the center of gravity of the airplane. And we'll talk a little bit about what the center of gravity means in a minute. You also see that I have some Velcro here on the bottom of the airplane. And this allows me to place the battery inside the plane and secure it so that if for some reason another plane take a violent maneuver or whatever, you're not going to toss your battery out. If you do that, you're going to be in trouble. So make sure that your battery is secured. If you don't use Velcro, use a strap of some sort or even a rubber band. It will hold it in place. Now, the radio that I'm using is, on this particular airplane, is called a 2.4 gigahertz radio. And that's one of the newer radios that are available today. And the advantages there are some advantages to the 2.4 gigahertz in the fact that basically you can fly anywhere and not have to worry about somebody interfering with your channel of your airplane. It's much like a cell phone, so each plane is specific to the receiver, each radio is specific to the receiver in the airplane, and once they're locked together, then you don't have to worry about somebody else interfering with your signal. Now, another advantage of the 2.4 gigahertz is you don't have a lot of antenna wire to deal with. However, you notice that the antenna wire on this particular system, which is a Futaba fast system, I want to be careful to keep my antenna wires on my receiver away from any parts of the metal airplane or the graphite, because they are conductive and they will act like an additional antenna, which may interfere with your signal on your radio. Now, if you're using a 72 megahertz radio, which a lot of people that are doing FPV prefer, because they are able to use then a 2.4 gigahertz downlink system, then the radios don't interfere. What I suggest is that you take the longer antenna that comes with the 72 megahertz, and wrap it around your fiberglass front upright, and make sure that you keep it away from any metal parts of the airplane. And that way you can be assured that your signal, at least from the airplane, is not going to be interfered with. Okay, so now we have our plane set up, ready to adjust the controls on it. I'm going to show you how some of the radio controls work. Now, I'm going to plug in the battery. First of all, you want to turn on your radio. And then I'm going to plug in the battery. And when I do that, you're going to hear a signal. I notice in this case, I've got my throttle at midpoint. The reason that I'm doing that is because I want to show you what happens. It takes, generally speaking, around 4 seconds for the speed control to arm once it sees zero throttle. And the speed control will not arm until it sees zero throttle. And that's a safety factor, so that if you inadvertently plug in and your throttle is up, the plane will not start running. So whether or not you leave it in the midpoint like this when you turn on your radio or have it down, it makes no difference. Just remember that it'll take a few seconds for the speed control to arm. So now I'm going to go ahead and plug in my speed control. and you're going to hear a beeping sound. And you heard 3 little beeps there, and that trill, because my throttle was down, means that my throttle is armed. That means anytime that I move this stick, which is my throttle stick, more or less like the gas on a car, it's going to run the motor. So you see that if you're working with your radio and you have your propeller in place and you inadvertently bump your stick, this propeller is going to catch you in a bad way. So make sure that your propeller is off when you're setting off setting up your radio. Okay, I want to show you how your radio controls work with the Hawkeye II. First of all, I'm going to turn on the radio. Okay, you always do that before you plug in the airplane itself. Next, I'll plug in the battery of the airplane, and when I do that, you're going to hear a beep sound. That's a very low sound. I don't know if you did hear that. You heard 3 small beeps. That's telling you it's a 3S cell. It's detecting 3 cells on the battery. Now, the motor will not run until it sees 3 or 4 seconds of 0 throttle. So I'm going to give it 0 throttle. I'm going to push the stick all the way down. And if you heard that little twiddling sound, that means that the motor is now armed. So this stick on your radio is your throttle stick. It's like giving the plane gas. So now whenever I give the plane gas, the motor is going to run. Now, this is why you want to leave your propeller off when you're setting up your radio, because if you inadvertently hit your stick, that propeller is going to spin at 1,000 revolutions per minute, and it's very sharp, and you can hurt yourself very badly with it. So be extremely careful whenever an electric plane is plugged in. Now, your other controls, and this particular airplane has what we call the CG option, is your up and down control. And that's this stick right here. So if I want to go down, I'll push the stick forward, and as you can see, this stick is moving back. If I were hanging, I'll show you that in just a minute. And what that's doing is moving the fuselage forward on the airplane sail, increasing the weight on the nose, which allows you to descend more quickly. And obviously the reverse of that is to pull back on the stick. And when you do that, it shifts the weight backwards on the airplane. Now, if you have a little difficulty, remember that. If you've watched airplane movies, you always hear them say, pull up, pull up, pull up. Well, if you pull, you're going to pull up. Pull is pull up. Okay, now, your next control, of course, is your steering. And this directs the direction that the airplane is traveling. Now, in this particular airplane, the Hawkeye, you have your rudder hooked onto the aileron channel. That's because the ailerons on airplanes are normally used to steer the direction of the airplane, at least bank the airplane so that it'll turn in the proper direction. In this case, I'm using the aileron channel on the radio, on the elevator, and it does the same thing. So if I want to make a right turn, I push the stick to the right, and the rudder goes to the right. If I want to go left, I push the stick to the left, and the rudder goes to the left. Now, so I have now my steering, left and right, up and down. Now, what I like to do is put my other control, or my rudder, which is actually the rudder on your radio when you get it, I'm using that to operate this servo right here. And what this servo is doing is it's tripping the camera shutter, so that whenever I push the rudder over, I'm going to turn the airplane around so you can see that a little better. Whenever I move the rudder over, it pushes the control down, presses the button on the camera, and the camera fires. Now, I've found that the best pictures are taken, or I get more good pictures, if I set the camera to shoot continuously as long as I hold the shutter down. That way, instead of getting 1 or 2 pictures, I'll get dozens of pictures. Now, sometimes at the end of the day, you'll have several thousand pictures, but they don't cost you any more money to shoot 100 than it does one. So if you have a lot to choose from, it's more likely you're going to get a good picture with your radio. I'm sorry, with your camera. So when I push down, you may be able to hear the camera shutter going. Okay, so these are your basic controls in review. Your throttle controls your up and down motion along with your elevator, or in this case, the CG operation. Now, when setting up your CG on the airplane, you want to limit the control of this, the throw arm here to the amount of travel that is allowed by the length of this bar. So when I push forward, I won't push any further forward than where it stops at the stop here, or reverse of that, pulling back. It will not try to pull it farther than the stop. And the reason that is you want to do it that way is that your servo gets overworked and it draws more current. When it's stalled out, that means it's trying to move someplace that it's not able to do it. And also there's a possibility that a repeated motion and bumping against this piece will actually push the piece off of the end of the rod. I mean, it is screwed on, but you want to avoid doing that. And the way you can avoid doing that is by adjusting your radio. And most new radios have that adjustment on the radio. You just have to look at your directions to see how it is done with your radio. So, okay, now I want to show you how to attach the sail to the airplane, and then we'll look at the controls once again, and I'll show you how the CG operates. So I'm going to turn off the radio and unplug it for a moment until I'm ready to do that.